Hello, everybody. Welcome to Applied Mathematics at Northeastern State University. This is our video number 3 for chapter 4. We started from video 0, introducing the class, and then video 1 for chapter 2, video 2 to chapter 3. Okay, so this is our video number 3. And chapter 4 is the last chapter in part 1. Including chapter 2, 3, and 4. And this chapter talks about actual application of mathematics for your personal finance. In this chapter, we used some of the concepts we learned from chapter 2 and 3, some really basic stuff about units, percentage, how to deal with numbers, etc., to do some really useful calculations in finance. Let's start from joke. Which kind of numbers is the best for your health? The answer is natural numbers. Why? Because they're natural. Get it? Oh, by the way, I got some feedback from video 0 and actually a few from video 1. Amazingly, a large percentage of people actually love mathematics, or at least part of it. So I'm really encouraged by that. Okay. Now, if you don't feel like you love it and you even hate it, don't feel bad about yourself. It's very common and natural. Hopefully, this course can help you to get rid of a little bit of your negative feeling instead of accumulate more of your negative feeling. Okay, and again, I want to emphasize that the videos I make here are not for the purpose of complete replacement of reading the book or watching all detailed videos from my math lab. Okay, my idea is to give you an overview of the chapter you're learning, so you can see the big picture. And I want to emphasize, talk about some real fundamentals and in depth, give you some examples to help you to understand a little better. And in the worst scenario, right, if some of you just don't like read books at all, at least you can learn a little bit from those videos. But one thing I notice is as the chapter goes on, right, there are a lot of more and more content in each chapter. I tend to talk more longer. Okay, I think it's probably not good for you. You don't want to watch a 50 minutes video. So I'll try to keep it concise down to about 20 minutes. Okay. Now this chapter 4, is a large chapter. Is a lot of materials in it. So I have to cut it off, like keep fundamentals information for you. Okay. So that's what I'm gonna do. Actually, a good thing about YouTube videos is that you can watch them anytime you want, right? You have it on your smartphone, on your pad, right? Like as an app. You can just pull it out and then just watch it, right? Let's say you do something else, right? I don't know, like maybe cooking or doing some housework. You can just open it, turn it on, use it as your background music, right? It's not as enjoyable as music, but it's still not too bad, right? So this way you can watch it or listen to it again and again and again and again, right? So after a certain number of times, you definitely understand it. Okay, let's talk about chapter 4. The title is Managing Money, right? And as you see here, there's 6 sections. This chapter is actually pretty heavy compared with the previous 2 chapters. And we decided to only cover the first 4 sections or 4 units. And it's not to say that the last 2 are not interesting. They're actually very interesting, okay? I would strongly recommend you guys to read those 2 sections sometime. It helps you understand a lot of things about your like income tax or the federal budget, right? These are all related to your own life. And okay, but we're going to focus on the first 4. Okay, now basically the first one, 4A, talks about some really basic about your personal finance, like income and expense, how do you balance the budget, etc., right? Now, and the second part, it talks about the most fundamental thing regarding about money. This is called power compounding. Okay, we're actually talking about so-called compound interest, and it's actually dominating everything. Whether you want to do savings like investment, or you want to do loans, both case, okay, this matters. Okay, it basically tells you how much money you need to put there to reach your financial goals, either to get the investment or pay the loan. Okay. Now the third part, it talk about something specific about saving plans and investment. Okay, like stock, bond, or cash, whatever you need. And it's kind of like qualitative explanation. And then finally, talk about loan payment, how to calculate. How we understand how it works. Like if you get a mortgage of 30-year fixed rate, and you decide to pay it off in 30 years, and with like a fixed given amount of principal, like 100,000 or 200,000, whatever, and then it can help you to figure out, given the interest rate, it can help you to figure out how much you need to pay monthly. Okay, now you probably already did something like that in your own life. Maybe buying a car or something, you need to pay monthly, and you never know where the number come from, and this explains to you where it come from. Hope this makes sense to you. Okay. In making video 3 about chapter 4, I originally made a very long video with all 5 points, but I realized that it's too long, so I cut the first 2 points off. There's only 3 points left in the video right now. It named the 3, 4, and 5. I put 1 and 2 in a different video. If you want, you can watch it, but it's not necessary. This the main one only have 3, 4, and 5 points. Only have 3 points. Okay, let's talk about point number 3. And actually, this starts point number 3, 4, and 5 that I want to make. They're all actual applied mathematics. So let's talk about point number 3 here. So we want to talk about compound interest. Okay. This is actually the most important concept in this whole chapter in terms of mathematics. Okay. If you understand compound interest, you can understand everything. Okay, of this chapter. Okay. So now, what is compound interest? Okay, let's take an example. Okay, suppose you have this $1,000 that you don't need. Okay, so you decide to do an investment visit, and then so that you can get more money later. Okay, let's say the investment you have is pretty decent one. Okay, it gives you 15% annual interest back. Okay, so this can be called an annual interest rate. Okay. Or sometimes it's also called annual percentage rate. Okay. Or the word APR. Okay, some of you probably know this word. Okay, APR. Okay, let's say this is 15% APR with $1,000. The question is, how long do you expect this money, your principal, right, to double with this 15% interest? Now, some of you may think, okay, each year I got 15%, right? So roughly speaking, the first year 15%, second year 15%. I just add them together. Now I know my mathematics, know my arithmetic, right? I know when I add about like 7 of them together, I get a percentage of 105. That's close to 100%, right? So another one maybe. Okay. So this means that I got this 105%. Okay, in 7 years. Okay. So I probably say that this is doubled. The amount is doubled in 7 years. That is actually not right. Okay. This calculation is wrong. Okay. Now, what's wrong about this is it means the fact that say you start from 1,000, right? It's 0, 0. Now, in the end of the first year, with this 15%, right? You can easily see that you got 1,000 and then $150, right? with this 15% interest, because the interest itself, you use 1,000 multiplied by 15%, you got 150, right? Added to it, the original price, original principal you have, you got this amount. Okay? Now, when you go from the second, from the end of first year to the end of second year, okay, things change. Okay, not only this 1,000 is getting interest, but this interest you got from the first year itself should be considered as the principal, and it itself gets new interest of 15%. Okay, so if you do this calculation, multiply, calculate the end and the second year, you get this amount at the second year. So third year, same kind of calculation. I'll just write down the numbers I got from my calculation. This way, save us some money. So first year, second year, third year, you got this amount. Okay, you keep doing this. In the end of fourth year, you got this amount. And in the end of the fifth year, amazingly, you got $2,011. So instead of needing 7 years to double your principal, you need only 5 years to double it. Okay, it's 5 years, not 7 years. Okay, that's what we call compound interest. Okay, the word compound here means not only the original principal is getting interest, all the interest you get on the way gets interest as well. This actually speed up the whole process of doubling your principal. Does that make sense to you guys? Okay, let's break down this calculation a little bit more so that you can understand it. Okay, let's say at the very beginning you have this $1,000, 1,000. Okay, in the end of the first year, you have to use 1,000 plus you multiply by interest, right? Which is 1,000 times 15%. Okay. Now, one way to simplify, you can simplify this version by writing it as 1,000 multiply 1 plus 15%. Okay. See, this 1 plus 15 is, if you multiply this into the parentheses, you got exactly 1,000, and then the second term is 1,000 times 15. So you can write this like this, right? Now, what about the second year? Okay, you do the same, but this time, this is your new principal, so you should use 1,000 times 1 plus 15% as your new principal, right? Now, this new principal get a interest of 15%. Okay, let me see. This is your first year. This is your second year. Okay. That makes sense. So this is your interest. This is your new principal for that year, and then this principal got a 15% of interest. Okay. Now you can write this formula similar to this one. This expression as the whole thing as your principal multiply this part here to get your total, right? This is your principal time plus interest, okay? Got it? So, and then certainly you can simplify like 1,000 times 1 plus 15% square, because you have two terms, okay? Now, you can do this for the third year and fourth year and fifth year, right? Now, we don't have time to repeat it, but as you understand, right? By the end of fifth year, you have this formula. You have this expression here. Okay, 1 plus 15% to the power fifth. Okay, just continue the trend we did before, right? So this number here, essentially, is just the number of years you're looking at. Okay, for each additional year, you just add this number by 1. That's giving you the total return in the end of that year. Now you can imagine actually in the number of nth year, right? This formula becomes 1,000 times 1 plus 15% to the power n. Okay, so this is actually a formula in the sense that it has both numbers and a symbol. So it's the algebraic formula. Now, a lot of you guys, based on the feedback, likes algebra. Okay, so for you guys, this is good. Now, for some of you don't like algebra, it is not that mysterious, right? This is just using a symbol to represent a number specifically. The advantage is you can easily just plug in the number for the symbol whenever you need it. Okay. Now, if you want to calculate 10th-year return, you just put 10 here instead of n. You can get, it's the same formula, just a different number you plug in. Okay. Now, if you absolutely hate algebra, you don't need to use this formula. You just go back to what we did in the previous page about how to, to calculate a specific year, how much you get. It's the same thing, essentially. So in some sense, algebra is just a shortcut for you to do your arithmetic. It's nothing mysterious. It's just a shortcut. Does that make sense? Okay, another point about compound rate is actually very interesting. Okay, see, so far we've been using this $100 as our principal, right, to calculate whatever return we get. And then we see that at the 5th year, this gives us $2,011.36, right? Now, however, we don't have to stick with $100, right? You may have $1,000. You may have $2,000 or $10,000, whatever, right? Now, we have a number that is not 1,000, right? What would we do, right? This part stay the same, right? So for the amount that we need to multiply, this part is the same. Okay. Now for the first part, we don't have to put $100. We just put our principals, which is the money we have at the very beginning of our investment. Put whatever principal we have here, multiply this by 1 plus 15% to the power n, right? And this can give us anything, any return we want, given a different principal. Again, I'm writing a formula here. The principal part is just like a symbol. You can put anything you want here for the principal you actually have, right? Now further, right? We don't necessarily have a 15% interest. Actually, for a lot of the investment, we don't have that, okay? Unless you invested with Warren Buffett like 30 years ago, right? His stock, he had a fund, okay? His Berkshire Hathaway stock, okay, has actually a pretty close to 15% annual interest. Most of stocks or bond you buy wouldn't have this very high interest rate. A lot of, like, if you put your money in a savings account in the bank, it gives you something like 0.5% per year now. You buy a bond, it gives you like 2% or something. So it doesn't have to be 15%. So in general, we will just write like this: principal multiplied by 1 plus interest rate, APR, annual percentage rate, multiplied by n, where you can write like year, okay, years. So again, this is a full formula, right, with whatever principal you have or whatever APR you have or whatever years you have, but it's very flexible, very general to use. You can just plug in a specific principal, a specific APR, a specific year, and you get this, whatever your return is, okay? So it's very convenient to use. That makes sense? Okay. The third point, still let's talk about compound rate, right? Let's go back to this 15%, okay? So 15% interest rate, okay? So based on what we see here, right? We see that if you put n equal to 5, the number you get here is about 2.011. If you multiply by 1,000, it gives you $2,000. So that means roughly 5 years, right? Your money is double. Okay. Now, what happened to the next 5 years? Okay. Again, because you repeat the same calculation, right? So for the first 5 years, okay, the money is doubled. It goes from 1,000 to 2,000. Okay. Now, what about 10 years? Another 5 years. Okay. Now, same calculation here. For another 5 years, it's going to double again. So in 10 years, you're going to get 4,000. Now, in 15 years, it's going to double again. You're going to get 8,000. In 20 years, you're going to get 16,000. Okay. As you see here, right, the power of compound rate is the compound interest is, okay? For the same amount of years, every 5 years, like in this case, 5 years, every 5 years, your money doubles, okay? It doubles, okay? So for money as small as $1,000, okay, after 12 years, you get 16,000, okay? Compare this with the original value, it's 16 times after 20 years. It's amazing. It's a huge return, right? That's the power of compound interest, because it keeps doubling, okay, for a certain amount of years, okay? Now for 15%, it takes 5 years to double and double and double. Now if you talk about something like 5% interest rate, 5% APR, it may not take 5 years to double it, okay? It actually takes about 15 years to double it, okay? But still, it doubles 15 years, and then it doubles again 30 years, and doubles again 14 years, okay? 45 years, okay? So the power of compound interest, it doubles and doubles and doubles pretty fast, okay? So so that's why Einstein said, I'm not sure whether Einstein actually said that or somebody else made up, but he said is the compound interest is the eighth wonder in the world. If you know what the first seven wonders are, I don't know them, but anyway, he says it's the eighth wonder of the world because it can double the money for you every certain amount of years. I think 5% APR is not very difficult to get using some bonds or some index fund, okay? But again, 15 years, it doubles. It's pretty decent. Okay? Now, what's the lesson here, okay? The lesson here is you can invest your money long-term, you get a lot more money, okay? Then you got more money, okay? And also it helps if you actually choose the investment that has a large, high APR, okay? If you have a high APR, it can double faster, and if you wait long enough, your money is gonna do this compound interest trick for you, okay? Essentially, we're talking about, this is actually called exponential increase. Because this increasing rate represents an exponential function, okay? We're not talking about functions here yet, but at least you know this is an exponential increase, okay? It's a fast increase you have in the real world, okay? Most times, this is the best you can get, okay? So I say, save some money from now, and then find a good investment for you. If not 15%, at least 5% annual APR, and then so that let it do compound interest for you, so that you can double your money every 10 or 15 years. Okay, that makes sense? And that's all I want to talk about on compound interest. Okay, let's talk about point 4 and 5, the two last points I want to make in this chapter. And I decided to combine them to one because I feel like it's pretty time consuming to talk about them. Okay, so let's start from point 4. Okay, so I want to talk about saving plans. Okay. And what do you get out of the saving? Okay. Now, let's say let's talk about annual saving. Okay? You want to save a certain amount of money per year. Okay, save money per year. Okay. Now, normally the compound interest calculation is interesting, but normally that's not how we save our money. Instead of putting a just one-time investment, we normally do it monthly or annually, right? So in this case, we're talking about annually, but the month case is the same, okay? Very similar. Now, basically, we're saying here, like, we like to put a certain amount of money every year to this investment, And we have a goal. Let's say we want to get a certain amount of money in 30 years or 40 years, right? The question is how much we can get given the money we put in every year, right? And how do we calculate that? Okay, essentially it's the same kind of calculation as the calculation we did for the compound interest. The difference here is because we have money input every year, right? So it's a little more complicated than the compound interest calculation. So the best way to do this kind of calculation is make a table, or you can use a formula, but it's kind of less direct. So let's try the table, okay? So I would make a table like this, okay? So I would say principal added per year, like one column, and then the total principal, and then interest I got each year, and then the return of the total return I have, okay? For example, you let's say you use this example, like say you have 15% APR, and then the principal you add is $1,000 each year. So the first year is certainly the same, and then interest of 15%, you got 150 as your interest, and then the return. Sorry, this is not just the 150, not 1,015. So the return is 1,150. Okay. Now added to it, then next year you add another 1,000 principal, so have a 2,150 as your total principal, and then you calculate the interest based on this principal, right? You got 322.5. So the total money you got in the end of the year is going to be 2,472.5. Now next year you add it to another 1,000, so it becomes 3,472.5, and you have to calculate the percentage of 15% based on this number. This gives you 520.88. Okay. Now in the end, you have add these two numbers together, you have 3,993.38. Okay. I think this kind of table is useful to do calculations. Okay. Just keep in mind, in reality, right, the principal you added here may be fixed, but it may not be fixed, right? You could say more, and then the interest here you got may not be fixed as well if you invest in stocks. So you better use some estimate, like rough number. I mean, bulk number for the estimate. So the return you get may not be very precise, but the bulk value is should be pretty good. Give you a guideline in terms of bulk number. Okay, finally, let's talk about loan payment. The idea is very similar to saving plans, but the order of those items are a little bit different. Okay, again, you can easily calculate it by break down to a table. Like in this case, because most of the loans we have, you have to pay like monthly. Let's consider a monthly situation, right? So let's say you have a total principal that you want to pay off. Let's say it is $10,000. Okay. Now let's say the interest, because you paid monthly, right? So monthly interest, okay. Let's say you have a 12% APR. That means monthly interest based on the normal convention is 1%. So 1%, you pay 1% in monthly interest, okay? And then let's say you have a monthly payment, okay? Now in the end, you have a principal left, okay? So start from $10,000 with 1% APR. I mean, sorry, 12% APR or 1% interest per month. It's pretty high APR though. You got the interest you need to pay is 100. Let's say you pay monthly 500. Okay. That means okay, this 500 is gonna first be paid towards the interest. Okay, so essentially you're adding the principal and the interest. This is the total amount. Subtract the monthly pay. So adding these two numbers, subtract that number. and then you get you actually only paid 400 principal. So what the principal left is going to be 9,600 after the first mass. Okay, so that's going to be your new total principal. Now for the second mass, again you have this one. You have to pay 1% interest. So it means like $96. If you also still pay 500, that means you pay 96 interest first, and then whatever left is paid towards your principal. So what is left is, again, adding these two numbers, subtract 500, you got 9,196. Okay, and you can continue this calculation. It's going to be a very long calculation, month to month, until you pay off your interest. Okay, but this gives you at least an idea of essentially how it works. And certainly, you can speed up this calculation by using a software like Excel for both the saving plans and the loan payment. Or you can use the formulas provided in the book. Although the formula look complicated, but they mean nothing but these tables. Or there's a lot of formulas on online or in the app you can use to calculate the loan payment for you, like how much you need to pay monthly in order to pay it off in 30 years or 15 years or 10 years, etc., etc. Okay. This finished this discussion of this chapter. It's a little long, but I hope it's illustrative. Okay. Now, in the end, let's talk about the today's question and to get a bonus point, right? Okay. Please tell me which part you think is makes sense that we talk about today, and which part you feel like does not make sense. Okay, and that is for today. Thank you for watching. I'll see you in the next video.